Good evening, students. So we are going to be learning something about friction today. Till now, we have learned about the various types of friction: static friction, kinetic friction, limiting friction, and how they act on the body. We have already known that friction is static if the block is not moving relative to the surface below. It is kinetic if it is moving relative to the surface below, and it is limiting if the block is on the verge of moving on the surface below it. Secondly, we have also learned that friction always opposes or tends to oppose the tendency of its motion over the surface. What does it mean? Like suppose if I have a block, let us say this is of mass m, and if it is having applied force in this direction, then the surface below it, let us say this is the ground and it is having some friction, it is rough, then the tendency of this surface, if I talk about, I am drawing it again, tendency of this surface is to go with the direction of force, then the friction on it will be acting in the opposite direction, somewhat like this. Friction on the block will be acting to the left, and friction on the ground, as per Newton's third law, will be acting to the right. So this is how friction is going to act. Suppose there is a situation where we have a lot of confusion. I'm going to draw three situations. This is the first situation. Block is moving with velocity v. It is of mass m. There's another situation. Same block. It is moving with some velocity v and some force is acting. Another case, same block. It is moving with some velocity v, but there is a force which is acting in this direction. So there is always a confusion among students in which direction there has to be the force of friction. Always remember one thing, friction acts in such a direction so as to oppose the relative motion between the two surfaces, which means if there is a motion already taking place, in all the three cases block is moving to the right, so motion is already to the right, the surface, lower surface, is going to have the slipping in the right direction, which means in all the three cases friction must be acting, it is kinetic in nature and should be in the direction opposite to the direction of its relative motion, or the direction in which there is a slipping or sliding. You need not to look at this, it is not relevant. If the block is already in motion, it will not be of any use. Friction will be acting as per the direction of motion. So in the first case, friction will act on the block in the left side. In the second case, again it will be acting to the left side. In the third case, it will be acting again to the left side. So it doesn't matter whether there is an applied force or not. If the block already is in motion, then the friction should be acting in the opposite direction to the relative motion. If the relative motion of the block is to the right, friction in all cases will be to the left, irrespective of there is an additional applied force or not. Whereas if the block is initially at rest and there is a force which is being applied over it, F, then there is a tendency of motion to the right. So because there is a tendency of motion, there may not be any motion. So friction in this case will be in the opposite direction to the friction applied force. So this is the first thing which we need to learn, that friction is not in the opposite direction to the applied force. It is opposite to the direction of slipping or direction of sliding. This is the first thing. And it will be static or kinetic depending upon whether there is actually a slipping taking place or not accordingly. So this is how it is. This is for the single block. Now let us take the case of multiple blocks. Suppose I have two blocks, somewhat like this, and the two blocks are kept over a horizontal surface. This block is of mass m1 and this block is of mass m2. Now, this ground is considered to be frictionless, whereas there is friction between the blocks of masses m1 and m2. Now, if suppose I am applying some force F on the lower block, we have to analyze how the two blocks are going to move. This is our question. First of all, if I am drawing the FBD of the two blocks, let's look at block of mass m1 and m2 separately. Correct? Let's begin with the m2 first. m2 is acted upon by its weight m2g. There is an applied force. There will be a normal reaction of the ground. I'll call it as Ng. And now see, this block is going to the right. It has the tendency to go to the right. There is no friction at the lower surface. There will be friction at the upper surface, and this friction must be acting in the left direction. This is Fi. Along with that, there will be a normal reaction coming from the M1 onto the M2 that will act in downward direction. It will be N. Now, this block is in equilibrium in the vertical direction, so there is no motion in the vertical direction, but it will move, or it may have the tendency to move in the horizontal direction. If it is moving in the horizontal direction, let us say with an acceleration a2, I can simply write in the horizontal direction F minus Fr equal to m2 a2. This is equation number 1 for the block of mass m2. Now let's come to the FBD of the second block, that block which is kept on the top. m1g will be acting vertically downward. Normal reaction N is acting in the upward direction. Of course, these two are balanced. Now the question is, in which direction friction will act, or how this block is going to move. In our day-to-day perception, we know that when I am applying force here, both of them tends to move in the horizontal direction. I can justify the motion of M2 by saying that there is a applied force acting on it, but what about M1? Which force is making this block move in the horizontal direction? Coming back, look at the FBD of M2. There is a friction acting on it to the left. As per Newton's third law of motion, friction will be acting on M1 in the right direction, somewhat like this. It is because of this friction which is acting in the forward direction, this block will have acceleration in the forward direction. So I can say that in this case Fr will be equal to m1 a1. This will be my equation number 2. Now listen to me carefully. I can write a1 equal to Fr by m1. a2 I can write as F minus Fr by m2. Now there exists a condition. If the two blocks are moving together, if the two blocks are moving together, if they are moving together, what should be the condition? First one, A1 will be equal to A2. If A1 is equal to A2, what does it mean? Fr by M1, F minus Fr by M2. If I simplify it, I'll get Fr 1 by M1 plus 1 by m2 F by m2, I'll get Fr equal to F m1 upon m1 plus m2. This is the frictional force which will be present between the two blocks. Now there is one more condition. If the two blocks are moving together, friction between the two blocks should be static in nature. This is second. Friction should be static in nature. What does it mean? I'll just do it here. Fr, which I am writing F m1 upon m1 plus m2, should be less than or equal to mu n. And from here I can write n equal to m1 g. So if I substitute, this is less than or equal to m1 g times mu. M will cancel from both sides. So this gives me applied force less than or equal to m1 plus m2 into mu g. That should be the applied force acting on block mass m2 so that the two blocks are moving together. Is that clear? So this is the first case which we discuss, where the block of mass m2 is being applied by force F and the two are moving together. Next is the case where the same force is applied on the upper block. What should be the applied force so that the two move together? That is going to be the discussion now. So I am clearing it up. Now the second situation, where we have two blocks placed on a horizontal ground and the applied force is on the upper block, somewhat like this. Again, this is frictionless and there is a friction between m1 and m2. How can we do it? Let's again draw the FBD. Drawing the FBD of the two blocks. You can say M1 will be acted by these forces. There will be a weight, normal reaction of the lower block, applied force, and because the tendency of slipping is to the right, friction acting on this block will be to the left. Somewhat like this. And because of that, it may get accelerated in the direction with an acceleration a1. From the previous knowledge, I can write a1 as F minus Fr by m1. Let's call this as equation number 1. If I draw the FBD for the second block of mass m2, m2g will act downward. Normal reaction of the ground ng will be acting in the upward. Normal reaction, this n will act downward. All these forces are balanced. Besides, there will be a reaction of this frictional force on block mass m2 that will be acting somewhat like this. It is because of this force, this block is going to move to the right direction with an acceleration a2, and I can write a2 equal to Fr by m2. These are the accelerations. Now again the condition arises, if the two blocks are moving together, if the two blocks are moving together, what are the conditions? A1 must be equal to A2, they have the common acceleration, which means F minus Fr by m1 should be equal to Fr by m2. This means Fr 1 by m1 plus 1 by m2 equal to F by m1. So Fr will be equal to F m2 upon m1 plus m2. Now what is the second condition? This friction must be static in nature. If this friction is static in nature, then this should be less than or equal to mu m. So I can say F m2 upon m1 plus m2 less than or equal to mu, and what is n? See from here, n is equal to m1g. So this is m1g. So applied force should be less than or equal to mu times m1 by m2, m1 plus m2 into g. That is the required force for the two blocks to move together. So in the first case we got F equal to less than or equal to mu times m1 plus m2 into g, whereas in the second case I am getting F less than or equal to mu times m1 by m2 into m1 plus m2 into g. So this is how the two blocks will move together.